Right? That's a real pen. Should not use that on the screen. So y equals x squared. So we'll use red here. So we have y equals x squared. Y equals 0. So that's the x, also known as the x-axis. X equals -2. So let's say, I don't know, let's say -2 is right there. And x equals -1 right there. So what region are we talking about? We have it right there. That's great. And we're rotating it about the y-axis. So we're taking it and rotating it around like that. So what's the first thing you need to do? What's our radius going to be? This one's a nice radius, right? 1 to 2 of what? And what's the height? Dx. That's it. Anybody have an answer they want to share for 16? Anybody have an answer? Anybody? Anybody have 3 pi over 2? 15 over 2 pi? 15 over 2 pi, so people think it's 15 pi over 2. Well, yeah, if you do this out, let's try it. Let's see what happens. It's going to be the integral of x cubed 1 to 2 dx. So it's going to be 2 pi 1/4 x to the 4th from 1 to 2. So that's going to be 2 pi times 2 to the 4th is what? 16 over 4 minus 1 over 4. So yeah, that's going to be 15 over 2 pi right there. The vertex, yeah, where it turns around, exactly. And that's going to be at negative b over 2a. So in that case, it's going to be -4 over 2 times 1. So the x-coordinate of the vertex is going to be 2. 2, right? And what is f of 2 going to be? 4 minus 8 plus 7. So what's that going to be? 3. 2, 3. So this right here this was 2, right? So remember the scale on this is pretty squished, right? Yeah, everybody understands that? Like the y scale. So 2, 3 is the vertex, right? So that's right here. Is that correct? So this thing goes up again. So what's this thing going to look like? Sorry. This is a parabola. It's just I'm drawing it with not a bad perspective, decent. So this is the region, right? And you're rotating around the what? The y-axis. So you are rotating around the y-axis like that. Exactly. So in this case, it's going to be 2 pi RH. Is it dx or dy? Dx. It's dx. And now, who said something about intersection points? Who said that? Yeah, Macy. You have to find those intersection points, right? So you have to set, just so you know, you have to set 4 times x minus 2 squared equal to x squared minus 4x plus 7. So you just have to solve this. That's 4 times x squared minus 4x plus 4 is equal to x squared minus 4x plus 7, like that. So 4x squared minus 16x plus 16 is equal to x squared minus 4x plus 7. So you end up with what? 3x. It's 3x squared minus 12x minus 9 is equal to 0. So that's 3 times x squared minus 4x minus 3 is equal to, so it's x minus what?
1
X minus 1 times what? You sure? That doesn't work. It doesn't. You can x minus 1, x plus 3. Does that work? No. X plus 1? It's almost always the setup on these that's challenging. It's almost always the setup. So just set it up, and you're right. It's the process. Absolutely. Factor out of both. So 2 times 2x plus x minus 2x squared plus x equals 0. Is that factorable nicely? 2x and x. Is that factorable nicely? Minus 1, right? Right, yeah. So what are the intersection points? X equal to -3 over 2 or 1. So the integral for this is going to be 2 pi from -3 over 2 all the way to 1. What's the radius? Y. And then the upper function is 2x, was it negative? Oh no, we need y. We need to just isolate x, right? Correct, because we're doing it with, so x is equal to 6 minus y over 2. So that's the upper, so it's what? Oh, sorry. Ooh, I see what you're saying. I'm sorry. Hold on. Hold on. You're absolutely right. Bill good today. What do we need to isolate? We need to x isolate x so we can get it in terms of y. So that's going to be 1/4 square root, right? Plus or minus, exactly. So this is x is equal to plus or minus 1/2 root, I'll write that cleaner, sorry. It's x is equal to plus or minus root y all over 2. Now here's the thing. We know that one of those sides is the positive, one of those sides is the negative, right? And we need to go from one to the other, but they're the same value. So what can we just say instead? It's just 2 times the positive. Does everybody see that? Why it's 2 times the positive? So this is 2 times root y over 2. This right here is the height. What else? We need the radius though, right? The radius in this case is what? Y dy. That's the first one. And what are we adding to it? 2 pi 4 to 9 of, and this is the one we were just about to set up here. You need the green here, but you need that in terms of, so x is equal to what? 6 minus y over 2. So it's 6 minus y over 2 minus the negative root y over 2. And what do we multiply on the outside? Y dy. You're absolutely right. This was a little nastier. So in this case, which method do you think is easier, shells or washers? Which one do you think? We are rotating around the x-axis. We are rotating around the x-axis. Yes, if we're rotating around the x-axis in terms of y for shells. But here's the thing. My question is, this right here, we have to do these two. This is the shells, right? Everybody sees that? Can we also write the same thing in terms of cylinders? Sorry, in terms of washers? I mean, in discs. Wow, I can't get my English right today. If we do it with discs, is it a lot easier? Yeah, it is. It's going to be the integral of pi, and we go from -3 over 2. This is what we were trying to do already, to 1, right? And remember, it's just this one, there is a hole in it. What's the upper so it's the upper radius minus the little radius dx this time, right? Draw this in little tiny pieces. In this case, we already have the upper we need in terms of, oh, you need to see it? You need it in terms of x, right? So what does y equal? Oh, and that really didn't help, did it? Y equals -2x plus 6. So what do you have here? Pi -3 over 2 to 1 of negative what? Thank you. Squared, right? Minus 4x squared dx. Is this a little bit nicer? They should theoretically, should they come out to be the exact same thing? Yes, absolutely. But in this case, it's a lot easier. And the way you notice that, generally speaking, if you can do one integral instead of two, is that almost always in your realm of calculus going to be easier for you? Yes. Almost always, everybody, one integral is going to be helpful, more helpful than doing two. Understand? Got it. Okay, so can someone just tell me what the, we're not going to do the limits yet, but can someone tell me what the R value is going to be? It's going to be what? 5 minus y. Very good. Yeah. Good job. It is 5 minus y because it's the distance from 5 to the y value. It's below it, so you subtract y from it. Very good. I like that. Excellent. At h dy. Okay, I'll let you choose. Do you want to do the limits of integration or do you want to do the height next? Okay, I'll choose. I want to do the limits of integration. So if we do the limits, we need to find the intersection, which is pretty easy to find. It's when x squared, sorry, excuse me. It's when x equals 4. So what do you do with that x equals 4? You just plug it in right there, right? So you get 16 minus y squared is equal to 7. So y squared is equal to 9. So what does y equal? Plus or minus 3. When you get answers like that, should it make you feel pretty good? Yes. So it's going from -3 to +3. Now the height we have to be careful about, right? The height. And the height is in terms of y. The height is in terms of y. So we know that what that value right there is x equals 4. So it's a 4. 4 is that value, right? And we need the distance from this line. We need it from that line to that curve. From that line to that curve. That's going to be 4 minus what? Well, we know that curve is x squared minus y squared is equal to 7. Is that correct? So what does x squared equal? 7 plus y squared. So this is going to be x equals plus or minus what? 7 plus y squared. Why is it plus or minus? It's plus or minus because there's a right-hand one and a left-hand one. Do we want the positive or negative one? Are the x values positive or negative for what we want? They're positive. They're in the first and fourth quadrant. So we want the positive one, so it's going to be that minus 7 plus y squared. That's going to be our h value. So what is our final integral? 2 pi integral from negative 3 to 3 of 5 minus y times 4 minus the square root of 7 plus y squared dy. Now they said set this up. They said do not solve. Why? Yeah, you can't. Because when you multiply this out, you're going to end up with a 5 times the square root of 7 plus y squared. So it really comes down to, can you integrate this? Can you integrate that? No, you can't. You think you might be able to use u substitution, but what is there not on the outside? There's no y to cancel out, right? You have a y squared on the inside, so you better have a y to the first degree on the outside being multiplied, or you're sunk. So are you sunk on this one? Yes. So what would you have to use? This could absolutely be a question on the AP exam on the calculator section. They could ask you to do this on your calculator. Do this now on your calculator and tell me what you get. Do this now on your calculator and tell me what you get.